For centuries, humanity has looked up at the night sky and asked the same terrifying question. Are we alone? We have searched the dry sands of Mars and listened for radio signals from distant stars, but we have found nothing but silence. However, the answer we have been looking for might be much closer than we think. Orbiting the giant planet Jupiter is a small, frozen moon that hides a secret, Europa. Beneath its cracked, icy surface lies a global ocean containing twice as much water as all of Earth's oceans combined. It is warm, salty, and rich in chemistry. It is the perfect home for alien life. But there is a catch. To find it, we have to do the impossible. We must drill through 20 kilometers of ice that is harder than granite, survive radiation that melts electronics, and deploy a submarine into an alien abyss. NASA has a plan to hunt for life on Jupiter's moon. But how? To find life, we first have to survive the landing, and Europa is not welcoming. It is less of a moon and more of a fortress. The first line of defense is Jupiter itself. The giant planet has a magnetic field so powerful it acts like a particle accelerator, blasting Europa with high-energy radiation. If you stood on the surface without heavy shielding, you would be dead in less than 24 hours. But for a robot, it is even worse. This radiation fries computer chips, scrambles data, and destroys sensitive electronics in minutes. Then, there is the ice. At minus 160 degrees Celsius, water doesn't behave like ice on Earth. It behaves like rock. It is as hard as concrete and tougher than granite. And this isn't just a thin layer. We are talking about a shell that could be 25 kilometers thick. Drilling through that with a standard mechanical drill is impossible. The friction would break the bits, and the radiation would kill the computer controlling it long before it reached water. We can't just dig our way in. We have to burn our way in. To defeat the fortress of ice, NASA engineers are building a robot that doesn't drill. It melts. They call it a Cryobot. Instead of spinning blades that would shatter against the granite-hard ice, the Cryobot uses raw heat. At its heart sits a nuclear battery, a radioisotope thermoelectric generator. On Earth, we treat nuclear waste as a problem. On Europa, we turn it into a weapon against the cold. As the radioactive core decays, it generates intense heat. This heat is channeled into the nose cone, heating it to hundreds of degrees. When the Cryobot touches the surface, the ice doesn't chip away. It screams into steam and liquid water. The robot sinks, letting gravity pull it deeper into the crust. But here is the brilliant part. As it descends, the water it creates flows up around its body and refreezes above it. The tunnel doesn't stay open. It heals shut like scar tissue. The Cryobot becomes a ghost, sealed inside the ice, leaving no trace behind it. The biggest challenge isn't melting the ice, it's staying connected. The robot needs to send data back to the surface lander, but radio waves cannot penetrate 20 kilometers of ice. The solution? A thin, glowing fiber-optic thread. As the Cryobot sinks, it unspools this cable like a spider dropping on a web. It is the robot's only lifeline. If the shifting ice snaps this thread, the mission is over. The Cryobot becomes a silent nuclear coffin, sinking forever into the dark. When the Cryobot finally breaks through the last few meters of ice, it enters a world that has been sealed away for billions of years. It emerges into a black, pressurized ocean where sunlight has never touched. The pressure here is crushing. strong enough to flatten a standard submarine. A single large explorer would be too risky here. If it breaks, the mission fails. So NASA isn't sending one explorer. They are sending an army. Inside the Cryobot's hollow body are dozens of tiny, torpedo-shaped robots called hydrobots. As the nose of the mothership tastes the ocean for the first time, hatches slide open, and the hydrobots deploy like a school of mechanical fish. Each one is no bigger than a smartphone, packed with sensors, cameras, and blue LED lights. They communicate with the mothership using acoustic pings, clicking in the dark like dolphins. The genius of the swarm is safety in numbers. If one is crushed by pressure or eaten by something, the others keep going. They spread out in all directions. Some head down, hunting for hydrothermal vents, volcanic chimneys on the seafloor that might host alien ecosystems. Others scan the ice ceiling above. They are tasting the water, sniffing for chemical imbalances, amino acids, or heat signatures. They are hunting for the faintest trace of biology. If the hydrobots find even the faintest sign of life on Europa, a simple cell, a strange organic molecule, a pattern that cannot be explained by chemistry alone, it changes everything. Because that would mean life didn't just happen once, on a pale blue dot orbiting an average star. It happened twice in the same solar system. And if it happened twice here, then the universe might be teeming with life. Galaxies full of oceans, moons full of strange ecosystems. A cosmos that is not silent, but alive. But getting that answer means gambling billions of dollars, decades of engineering, and trusting a nuclear spear and a swarm of robotic fish to survive one of the harshest environments we've ever attempted to explore. Humanity is, once again, betting everything on a question. Are we alone? NASA believes that to find the answer, we have to go where the odds are highest. Not to Mars, not to Venus, but to a frozen moon, locked in the shadow of a giant. A world of ice hiding an alien ocean. Somewhere beneath that ice, the universe might already be alive. And one day soon, as a tiny signal fights its way back across the void from Jupiter to Earth, we might finally hear Europa's reply. Join us next time as we explore more mysteries of the universe.